Here's the most important thing, I think, because anybody can do this. Measure the horizon dropping as you go up in height. They put up a quick picture again to show you the equation that you use. Here's the deal. When you first start running the numbers about, like, should you be able to notice the horizon dropping, and the number of degrees is pretty small, like even up in a plane, right? However, if the number, it doesn't matter if the number is small. What matters is, do you have equipment that is sensitive enough to measure it? Okay, and check this out. This is pretty neat. If you have a typical camera, let's say 35 degrees field of view, and it has 4,000 pixels in the vertical. Okay, if you go up 800 feet, all right, which is the height of a tallish, like, skyscraper, like 75-story or 60-story building or something like that, which they have those buildings everywhere. If you calculate how many degrees should the horizon drop at 800 feet, that equates to 57 pixels in a camera. You should be able to measure that. In fact, I think anybody should be able to measure this. Now, I just want to say this, that you can probably convince yourself with a level and a camera, maybe a tripod, go to a nearby city, get up onto the roof of a tall building. You should be able to convince yourself if the horizon has actually dropped compared to when you're on the ground. But if you want to convince the world, if you want to get a video of this and put it online and convince everybody, you're going to have to be more scientific about it. So the first thing you have to do is you have to align a level with your camera. Okay, now you can do this if you buy a piece of, like, aluminum, attach a level to the piece of, like, aluminum and attach the camera to that. You want to make sure that the mount, which is this piece of metal I'm talking about, you want to make sure that the mount itself is not flexing. You could use perhaps something like this to reinforce your mount. You can purchase these at, like, Home Depot, but a nice solid piece of metal, maybe reinforce it with a couple of these sort of spines going down it to stop it from flexing. Attach your camera to it, attach a level to it, so that you know that when you're looking at the level, that the camera is in the exact same position. That the whole point is that you want to be able to make measurements over and over again, so that you know that if the level is flat, that the camera orientation is the same each time that level reads the same thing. Now, the best thing to do would be to have two cameras, point them in opposite directions, align them, right? So what you could do is put it on a tripod at a certain height, okay, align it with a level, put a mark, like, on a wall in a room, and set the mark at the same height as the camera. In one camera, you want that mark to be in the center of the image, and then rotate the tripod and verify that the other camera is also right, has that spot right in the center. Okay. If you want more information about this, I'd be glad to help. Send me an email or something. Maybe I can make another video that would describe how to create such a mount. What the purpose is that if you can get, see, if you show in a camera that the horizon was at a certain pixel level, and then you go up in a building and now that horizon is lower, how do you know the camera isn't tilted? Well, you can sit there and you can read the level, but the best way would be to have two cameras pointed in opposite directions. If you're tilted, if the horizon has dropped on one, it should raise on the other. Okay, so the whole goal would be to be able to have two cameras aligned so that they're perfectly pointing straight, and you can go to the top of a tall building, 800 feet or so, measure the horizon, show that it is below the center of the image, and actually show it simultaneously in both cameras. Hopefully that makes sense, but if you're looking for one experiment that you can do that would definitively prove whether the Earth is flat or round, that is how you do it. Anybody can do it. So I think that's the one thing this whole like internet conspiracy theory is missing, is definitive proof. I don't know why nobody's done this yet. People have attempted to do it. Like I guess the main reason is that like nobody's done the calculations and figured out that a normal handheld camera is sensitive enough to measure that drop. So I'm excited about seeing what the results are. Maybe if I can get to a nearby city. Also, it would be best if you could go to a tall skyscraper that's like along a coast where you can look out over the ocean in two different directions. That'd be the best way to do it. But anyway, so there you go. That would be how you prove it. Get accurate measurements. It might turn out that the horizon does not drop at all. If that's the case, then the Earth is flat. Maybe the horizon drops, but not as much as the round Earth theory would predict. Well, that would indicate that the Earth is much larger than we've been told. Or alternatively, the horizon drops exactly the amount you would expect it to, in which case, then I would say the Earth is in fact round. So, anyway, yeah. This video is finally over. Huzzah!